Hello, I'm Rupert Verco, CEO of Cobra Resources PLC. Welcome to a Wudinna project update, where today I'm very excited to talk you through the project's maiden rare earth resource estimate. So, our maiden rare earth resource is a unique clay-hosted rare earth occurrence. It's very unique and has a competitive market advantage because it overlies defined and growing gold resources. So we believe that that is going to be a unique catalyst that will hopefully strengthen the commercial acumen of the Wudinna project in comparison to other rare earth focused plays. Why it's really important is the fact that not only are we defining further value from dual outputs, being both gold and rare earths, but environmentally, it produces a potential project that reduces waste and increases the metrics for a low cost, low carbon output style operation. What we're also excited about is we've defined whilst we've defined a significant rare earth resource over the top of defined gold mineralization, we're also defining a significantly scalable rare earth occurrence across a significant land tenure of the Wudinna project. Our maiden rare earth resource coincides with the Baggy Green and Clark gold deposits. So the mineralization occurs within the saprolite zone that overlies over 94,000 ounces of gold at the Baggy Green prospect, and the Clark prospect, which currently sits outside our 211,000 ounce resource, where we've defined over 500 meters of gold mineralization. So some key takeouts of this maiden rare earth resource is one, is a baseline that is very much constrained to the work that we've done. So the estimation is open in multiple directions, and that is very much limited to the drilling or the reanalysis work that we've done. So we see significant upside, but what is most important about this estimate is it's going to enable us to start evaluating the commercial outcomes from these dual commodities, being rare earths and gold. In addition to our rare earth resource estimate, we've also announced a significant exploration target at the Thompson prospect, where we have some broad space drilling that is defining some exceptional metrics that we believe has the potential to quickly add to our maiden rare earth resource. So if we're looking at an exploration target of 81 to 233 million tonnes that we aim to start to drill and infill drill with the hope to bring this into our resource over the coming months. Something that I think is important to touch on is the cost-effective method in which we've been able to generate this maiden rare earth resource. A little over 12 months ago, we first identified rare earth mineralization above gold mineralization at Clark, and over the last 12 months, we've very diligently gone through a process to, one, not only grow that occurrence, but two, to understand the mineralogy and the metallurgical potential of those rare earths. So what I'm going to do now is just talk through some critical components of both the mineralogy and what we believe that will enable going forwards as we devise a plan, a strategy to improve metallurgical recoveries of rare earths, and with the aim of defining positive economics for the project. So after some initial mineralogy analyses done by the CSIRO, we submitted samples from 2 gold-bearing holes at the Clark Prospect for standard desorption and leaching testing at the world-renowned ANSTO facility over in New South Wales. What this work demonstrated to us is we had a component of colloid, high component of rare earth bursary was potentially colloidal phase, which is a chemical phase of mineralization where the rare earths are bound to the clay particles. So as we're committed to defining environmentally considerable metallurgical processes, we believed that we needed to further understand our mineralogy to define the best pathway forward to study the metallurgical potential. So something that was critical in our understanding of what we potentially have was some spectral electron microscope analyses that was carried out by the University of South Australia. What this study did for us is it enabled us to understand that, one, we had enrichment of rare earth bearing mineral phases within our hard rock that is associated with the gold mineralization. Why is it associated? Well, epidote is a key alteration mineral that occurs peripheral or halos gold mineralization, and that was enriched in rare earths. What is also important is that we have a secondary phase of rare earth minerals that occurs within the sap rock, and that's demonstrating that the primary rare earth minerals have been broken down and they've reformed. These secondary minerals are much more amenable to being leached and the rare earths being remobilized. So they're critical components that we need for the for ionic absorb style deposits that occur in southern China. So something that we went and did through that SEM work was looking at the total sample percent or volume percentages of those mineral phases and how they coincided with our downhole grades. And there were some critical components that really stood out to us. So if we look at this graph, we have a very high occurrence of primary phase minerals that are associated with gold mineralization in this hole, and they progressively decrease as we get shallower in the hole. Proportionally, we see an increase in those secondary mineral phases. But higher up in the saprolite, we have a significant zone of elevated rare earths that are not directly associated with both primary or secondary phases. So that in itself says to us that we have a zone where those rare earths are potentially absorbed to the clay particles. So that's one critical component. And what that led us to theorize was, well, MET testing has demonstrated that we have recovery potential that would suggest that we have colloidal style mineralization. What are the environmental conditions that we would require to promote further ionic absorption as opposed to colloidal mineralization? And key literature demonstrates that there are acidic conditions being slightly acidic, so in a pH range of 6.2 to 6.8, and also other academics have demonstrated that the process of absorbing rare earths to clays, called physisorption, is possible under highly basic conditions that's optimal at a pH of 10. So that led us to theorize that with our gold mineralization, we have considerable amounts of sulfides, and we know that we get a process called supergene enrichment of gold occurring on a base of saprock, which is owing to increase in acidity that is driven by the breakdown of those sulfides. So we believe, or we theorize that the breakdown of those sulfides, can that lead to the conditions that are most optimal for ionic absorption, being a pH of 6 to 7? And if so, how do we best target this? So we know we have the right style of clays. We want to find zones where we see a redox boundary or a discrete change in acidity in the saprolite. So what we did is we went and did a significant amount of pH testing across a number of, a lot of samples that we've drilled over the year, and RC holes from the previous year. And what this work really started to demonstrate with us is some very strong correlations between rare earth grade, magnet rare earth abundance, and those critical conditions or those acidities that are best promote ionic absorption. So here we see hole 28 with a considerable grade peak, an enrichment or a higher percentage of magnet rare earths, and we see that acidity sitting at around 6.2, 6.3 over that intersection period. And not only is that important, but when we look at the data set as a whole, one critical component stands out, that the grade at a pH 6 to 7 and a grade at a pH 9 to 10 is a fact or considerably higher than the grades in any other acidity conditions or alkalinity conditions. So at pH 6 to 7, we have a grade average that is nearly 1750 ppm TREO, and we see a proportional, the highest proportion of magnet rare earths at those conditions, and the lowest cerium content. So cerium's your lowest value rare earth, and that's a very important aspect that is characteristic of those ionic absorption style deposits in southern China. So this has led us to theorize that, based on focusing on the acidity conditions of our saprolite, we can define zones that are more amenable to higher recoveries through those standard desorption processes. Additionally, what that work has demonstrated is the potential for us to apply a very cost-effective process to reclassify our defined resource into a mineable reserve. So what do I mean by that? Well, if we look at a standard intersection from our data set at Clark, where if we were to apply a cutover grade of 350 ppm total rare earth oxide, most of our average intersections would sit at around 650 ppm TREO, which is very similar to the grade reported in our maiden rare earth resource. However, if we were to analyze the data set and project it at a pH range of 6 to 7, our grade is not only beneficiated to over 1700 ppm TREO, we see a significant increase in the quantity of the high value magnet rare earths, being neodymium, praseodymium, diprosium and terbium, demonstrating increased value and hopefully increased recovery potential. So what we've done now is we have a number of samples with a metallurgical laboratory looking at desorption of samples to verify our theory here. And what we're hopeful of seeing is improved recoveries at these conditions, which will give us a great baseline from which we can then apply and devise our 2023 exploration strategy. Going forward, what have we got to look forward to? Well, we've got plenty of action happening in the first half of 2023. We expect to have RC results from our 2022 Clark drill campaign, and they should be imminent. On the back of that, we expect to have our finalised results of our TEM, our ADI co-funded geophysical survey at the Clark prospect. Additionally, what this will do is, in collaboration with the Loop TEM, will give us a much deeper resolution of the structural controls on gold mineralisation at Clark. On the back of that, we expect to see first phase of rare earth metallurgy results, and those results will then lead into optimization studies, which we currently already have bulk samples in at the University of South Australia, where they're looking at beneficiation potential and defining processes that enable or may enable the catalyst for economic recoveries of our rare earths. We're hopeful to be starting our drill campaign in late February, which will go through March and into April, where we will be RC drilling and air core drilling across a number of prospects that will include Clark, Baggy Green, Barnes and Thompson. And what that will culminate in is particularly a gold resource update. We've now done over 10,000 metres drilling since our 2019 gold resource, and hopefully it will also accumulate into an additional rare earth resource update. So lots happening. We look forward to keeping you updated of our progress and as results come in. In summary, what we believe the Wudinna project presents is a very unique investment rationale. It provides two high value commodities that are commercially beneficial to one another, in that the rare earths are potentially sitting within a zone that would traditionally be overburdened, and we believe that that has the commercial potential to set this project aside from other rare earth focused projects. What we've done over the last 12 months is we've demonstrated significant scalable potential of those rare earths. We now have over 15 prospects where rare earths have been intersected, and some of them are very scalable, such as Thompson, where we have an 81 to 233 million tonne exploration target. So we're poised for growth. We currently have 500 metres of gold strike defined outside of our defined gold mineral resource estimate, and we have further RC drilling planned to expand on this and to infill and grow the footprints of our rare earth resource. So it's a very exciting time for Cobra. Thank you for listening, and we look forward to keeping you updated of our progress.